Now, it is time to dive into the details. As a citizen data scientist candidate, you may find it daunting to consider the use of analytical techniques and algorithms, but there's no reason to worry, because the augmented analytics solution you will be using is designed to recommend and apply appropriate techniques and to perform the analysis required so that you can review accurate, clear results and use those results to make decisions. While it is not necessary for citizen data scientists to become expert in each of the analytical techniques listed here, the personal and organizational transformation from business user to citizen data scientist will require a basic understanding of these techniques. That understanding will come with time, but for now, this introductory brief should help you grasp the essentials and the fundamentals of these techniques. The techniques you see listed here are those we will review in more detail. By the end of this course, you will have a better understanding of each of these algorithms and techniques and how and when they can be applied to gain insight into your data. One important note to keep in mind as we review these techniques: further information and detail on each of them can be found in the online background and support documentation for this course. The first technique we will review is used to identify trends and patterns. As you can see from the graphics presented here, trends and patterns might be applied in one of several ways. A seasonal pattern analysis will help you to identify fluctuations over a fixed period, not to exceed 1 year, so that you may identify seasonal trends and plan business accordingly. One can identify a seasonality pattern when fluctuations repeat over fixed periods of time and are therefore predictable, and where those patterns do not extend beyond a 1-year period. Seasonality may be caused by factors like weather, vacation, and holidays. It usually consists of periodic, repetitive, and generally regular and predictable patterns. Seasonality can repeat on a weekly, monthly, or quarterly basis. Cyclical patterns highlight fluctuations that do not repeat over fixed periods and are therefore unpredictable. These fluctuations may extend well beyond a year. A typical business cycle consists of a period of prosperity followed by periods of recession or depression and then recovery, with no fixed duration of a cycle. During a recession, employment, product, and other factors are below the long-term trend lines. In good economic times, people have more disposable income and are willing to take vacations and spend money. The last example of trends and patterns applies to random analysis, which identifies fluctuations that are short in duration, erratic in nature, and follow no regular pattern of occurrence. Trend and pattern analysis might be used in industries like retail or travel for seasonality or weather forecasting, crime forecasts, or any one of a number of other applications. Now, let's take a look at the concept and technique of sampling and the two types of sampling used in analytics. One would use a sampling technique when working with large data sets. Simple random sampling is based on chance, and every item in the analytical dataset has an equal chance of selection. A lottery system might be an example of an area of focus for simple random sampling. Another example of this type of sampling might be applied if we wanted to find the average value of all cars in the United States. Random sampling is less time-consuming and economical in nature, but there is a higher chance of bias, and it is often difficult to get a good representative sample. Stratified sampling considers a population of data divided into subgroups with similar attributes and characteristics, defined as strata. A random selection of samples from each of these subgroups is taken in proportion to the size and defined scope of the subgroup to identify a stratified random sample. Stratified sampling is also economical in nature and is not time-consuming, but there is less chance of bias than in random sampling, and higher accuracy. For stratified sampling, you can define categorical variables for subgroups like age, gender, education, income, and others. Businesses might use sampling to identify a test group for research, for product testing, for media or political targeting, or for other purposes. Simple random sampling is economical in nature and less time-consuming than other techniques, but there is a chance of bias, and it is difficult to get a representative sample. Stratified random sampling is also economical and less time-consuming, and there is less chance of bias and higher accuracy than in simple random sampling. You will need to define the categorical variable by which subgroups should be created. For instance, the age group, gender, occupation, income group, education, religion, region, or other variables. The analytical technique that identifies and analyzes outliers is designed to isolate and illustrate these data points or items in your data set that are outside the central parameters of the data set. An outlier is an element of a data set that distinctly stands out from the rest of the data. In other words, outliers are those data points that lie outside the overall pattern of distribution. Univariate outliers are identified when analyzing a distribution of values in a single feature space, while multivariate outliers are identified in datasets with multiple feature states. When considering the cause of the existence of outliers, the reasons might be data entry errors, data processing errors, sampling errors, or any one of several other factors, including the natural cause, which does not emanate from an error but rather is truly a unique point in the data. Once you have detected outliers, you can gain further insight to determine whether the outlier data points represent items that are so far outside the norm that they need not be considered, or whether they illustrate a very unique and singular category or variable that is worth exploring, either to capitalize on a niche or find an area where an organization can offer a unique focus. When considering the use of outlier analysis, a business should first think about why they want to find the outliers and what they will do with that data. That focus will help the business to select the right method of analysis, graphing or plotting, to reveal the results they need to see and understand. And it will also help the business decide whether it should remove outliers or include them in its analytical methodology. It is important to recognize that when the outlier analysis is applied to certain data sets, the results will indicate that outliers should be discounted, while in other cases, the outlier results will indicate that the organization should focus solely on those outliers. For example, if an outlier indicates a risk or a mistake, that outlier should be identified and the risk or mistake should be addressed. If an outlier indicates an exceptional result, such as a person that recovered from a particular disease in spite of the fact that most other patients did not survive, the organization will want to perform further analysis on the outlier result to identify the unique aspects that may be responsible for the patient's recovery. When a business uses outlier analysis, it is important to test the results and analyze the overall data set and environment to be sure that the presence of outliers does not indicate that the data set may be more complex than anticipated and may require a different form of analysis. You might think that a few dangling outliers in your data would be unimportant. After all, those outliers do not reflect the mainstream data. But detecting outliers is of crucial importance to businesses and organizations that focus on research, physics, finance, economics, and technology considerations, and cybersecurity and machine learning. The outliers technique is the final technique we will discuss in this section. In the next section, we will continue our review of algorithms and analytical techniques, beginning with forecasting.